Okay, so thanks for coming back for more help with these proofs. We will start with the next one. That would be number 29. So let me create my statements. This one's a little bit bigger in my reasons. Sorry, I might have to squish them in here. So our statements, we always start with the given. AC is congruent to DC. Angle A is congruent to angle D. And that is, of course, given to us. Alright, so let's mark some things on our picture. AC is congruent to DC, so there's a pair of sides. Angle A is congruent to angle D, there's a pair of angles. So we need to prove that angle B is congruent to angle E. So I'm going to do that in blue. But we don't know that yet. So remember, we probably have to prove two triangles congruent. We probably have to prove that this triangle is congruent to that triangle first, okay? And then we can use that clever CP-CTC to say that angle B and angle E are congruent. So let's look at our two triangles and ask ourselves, can we get a third piece of information? Well, if I look at the picture, this angle and that angle, they are vertical angles. And by the vertical angles theorem, they are going to be congruent. So let's make sure we get the correspondence right. We'll go angle ACB is congruent to angle. Now A corresponds with D, C is the vertex, and then E. There we go. Those two angles are congruent by the vertical angles theorem. And there's another pair of angles. So now if I look at my picture, angle, side, angle. I have that the two triangles, let's call them triangle, same correspondence as above. Triangle ACB is congruent to triangle DCE by angle, side, angle. Angle, side, angle congruence. And now, since those two triangles are congruent, we know that their corresponding parts are congruent. Angle B is congruent to angle E, and that's that CP, CTC. Corresponding parts of congruent triangles are congruent. And there's that proof. Okay, back in business with number 30 here. Alright, the next proof. So we'll create our statements and our reasons all the way down. And we'll start with the given information as always. Segment AD is congruent to segment CB. Segment AB is congruent to segment CD. That's all given to us. And let's mark that on the picture. So AD is congruent to CB. AB is congruent to CD. So if I look at my picture, I'm on my way to proving triangles congruent. I have a side and a side. I have two sides. Now, we want to eventually prove, so I'll do it in blue, that AD is parallel to BC. In order to do that, I guarantee we'll probably have to use this idea of them being parallel and then a transversal going through them, so that alternate interior angles need to be congruent. So for those alternate interior angles to be congruent, I bet we should show that these two triangles are congruent. Okay? Now, the question is, can we do that? We have two sides right now. Can we do that? Well, look at your picture. AC touches both. There's your reflexive property. AC is congruent to AC. Reflexive property. So if you look, we have by side, 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 we now know that triangle A, CD is congruent to triangle, so ACD. How about we name it a different way? How about we name it ADC? Triangle ADC is going to be congruent to triangle CBA. Okay. I think it's just easier to see A down B, down the side with one marking. C down the side with one marking to B. And that is by side, side, side. So now, since the triangles are congruent by CP, CTC, we know that these two angles, so those angles are angle, we'll call it DAC. DAC is congruent to BCA. DAC, BCA. This is by corresponding parts of congruent triangles are congruent. CP, CTC. Well, if we look at these angles are alternate interior angles. And if alternate interior angles are congruent, then your lines are parallel. Okay? So, we can prove that AD is parallel to BC. Since you're proving lines parallel, remember, it is a converse to a theorem. Converse to alternate interior angles theorem. Okay, and there are what you want to prove, that those two lines are parallel. Okay, one more proof coming up. Okay, so our last proof coming up here. Create our statements and reasons. And so always start with the given. So segment MQ is congruent to segment PQ, and we also know something about this angle 1 is congruent to angle 2. So on my picture I'll mark MQ congruent to PQ, and angle 1 is congruent to angle 2. Now eventually we want to show that MN is congruent to PO. Eventually, right? So if we look at the triangles, angle 1 and angle 2, okay? Angle 1 they're in this smaller triangle. But look at these two sides, the one we have and the one we want to prove. See the triangle they're in? This one's in triangle MQN, this one's in PQO. Those are probably the two triangles that I want to focus on proving congruent. If I can prove they're congruent, then I can say by CP, CTC that those sides are congruent. So let's see how I can do this. Well, right now, I have a pair of sides. Right now, MQ and PQ. Now, what can we do with angle 1 and angle 2? Remember, converse to the base angles theorem. If two angles in a triangle are congruent, then the sides opposite those angles are congruent. The side opposite angle 1 is QO. The side opposite angle 2 is QN. They are going to be congruent. And luckily, they are part of the two triangles we want to prove congruent. Okay? So let's say that QN is congruent to QO. QN is congruent to QO. Converse to the base angles theorem. Converse to the base angles theorem. So now we have two sides congruent. The two sides in red. Can we find a third thing? Well, look right in between them. Oh, sorry, not green. Right in between them, you have vertical angles occurring at Q. Vertical angles are congruent by the vertical angles theorem. So that means that angle MQN is going to be congruent. MQN is congruent to PQO by the vertical angles theorem. All right, vertical angles theorem. Vertical angles. So this is a pair of angles. And now look at my two triangles. Side, angle, side, side, angle, side. I have proven those two triangles congruent. So we'll just use the correspondence above. MQN is congruent to triangle PQO. And again, that's by side, angle, side. And I wanted to show MN, segment MN is congruent to segment PO. I can do that now. Now that I have the triangles congruent, I can say that their corresponding parts, MN and PO, are congruent. and that is of course by CP/CTC. Okay, so I hope these videos help you just feel more comfortable with the proofs and do well on your test on Friday. Alright, thanks for watching. Bye.